It's somebody from Australia down there in the floods.
Yep. Well, welcome everybody to our meeting today. This picture is from 2010 that you're looking at. I think several of you were here. I notice. I see John smiling, and yeah, that was the Parallax Expo, and we had about 2,000 people there over a 3 or 4 day period. And wow, we had a lot of fun. And the highlight was definitely this was one of it. Rick's Gatling gun paintball shooter, which shot 2,000 paintballs per minute and took our 90-gallon, everything our 90-gallon air compressor had to offer. And another highlight, of course, was when the quadcopter was flown. This was before the rules were coming into place. When we were flying a quadcopter with gyroscope only, no accelerometer for auto level, over first-person view from within the building, Nick or Kevin holding the transmitter and watching it over video, trying to orient themselves with kind of primitive tools. And there are a whole bunch of people lined up outside for tours. And we got word the quadcopter was returning to home base kind of hot. And it came in very hot and smacked into the side of the building and exploded in a million pieces. And everybody cheered wildly. I don't know if anybody online saw that or not. But that was pretty crazy day. Anyway, we're just looking forward, thinking about when we can have an expo at Parallax, and so many things will happen based around this possibility. We have some work to do around our office, but just don't know if it's going to be the end of this year or more realistically, if we're looking at 2022. You know, it's starting to feel like 2022, but we'll see. So, you know, that's fine if it is, because everybody will have 9-month warning. Anyway,
when it does.
Yeah. You have any impression on that? 2022 is more likely, huh? What's people's gut instinct?
Probably a better idea.
You're more sure, isn't it? Yeah. And that's fine. So pretty soon we'll be able to plan that. So today I see that we have lots of people here, and I know there's some interesting topics. Some of them I'm aware of. Pnut command line compilation from Chip. Chip's done also a power test. If Carol Hazlitt shows up, I know she's got some questions about the MicroPython interpreter because she's been using it. And I see Eric Smith is here, and some people end up having to run off to work. So we want to try to address anything they've got first before they end up going to their other jobs. So what other topics have we got?
I also have test results for Chip and for Eric from running under Visual Studio Code.
Okay. Good. And then Eric, do you have anything in particular? Is that for real? You turned into a mouse.
You have a voice mod on. Sure.
I think your kids have been using your computer.
Yes.
All right. Well, hopefully you'll return in the non-mouse version.
Yeah.
Maybe use the chat, Eric. It's just sort of crazy and funny at the same time.
Or turn off the helium.
Yeah. So what other items are of interest to people here that have, you know, any burning issues support-wise, or just kinds of questions that are going on, or topics to share, anything like that? Okay, well, I'm sure more will come up. Well, then how about if Eric is back in order, maybe we should share, Stephen, your work first with the VSC.
Okay. Yeah, I've got nothing visual for us to show.
Just talk about it, it's fine.
Yeah, exactly. Can you hear me okay?
You're good, yeah.
Okay, good. Chip released a batch file that allows us to run and get the error reports, and Chip, I report to you that that works after a little coercion. When we install Pnut, it doesn't have a formal installer. And so the batch file was created with no pathing information to the exe itself, to Pnut, which means then that we have to configure the Windows environment to be able to find Pnut automatically, irrespective of where the batch file lives. And also the batch file probably can't write the error text file where the batch file lives anyway. So it wants to run from wherever your project is. So
okay. So
I got to
we're gonna-
figure out, right, I got to figure out how to set the path correctly in the Windows environment. Once I get that working, I was able to demonstrate by putting in path information, I was able to demonstrate that error reporting actually does work. Visual Studio picks it up just fine coming from the batch file, and all the highlighting happens the way it should. So we're on the path to success there. The other thing you could do in the batch file is remove, every time it's run, let's remove the previous error text file.
Yeah, I had it doing that at first, but then I set up the application so that it cannot exit without writing error.txt.
Okay,
But
But
should we delete it anyway?
right, which is great if it runs the application, but when it doesn't, it just shows me the previous one.
Oh, okay.
Yes.
So if you
Remember, I
have the
couldn't
path
find
right,
Pnut in my case.
okay,
Right.
gotcha. All right.
And so that'd be an extra safety. I'm like, why is it still reporting an error and telling me it can't find Pnut? So
Okay,
that
so
was-
I'll say
that was an interesting
DL
behavior.
error.txt.
Yeah, so it's just a safety thing, and it's remove versus empty it too, probably.
Oh, wait, remove?
Remove the error.txt file versus just put an empty one out there.
Yeah, so I'll put after in the second line of the batch file, I'll just put del error.txt, right?
That's probably right, correct.
Okay.
Or do it before you run Pnut.
Add a
I
slash
don't know, whatever
y.
you want to do it.
That's when it happens.
I think it's add a slash y to ignore the "Are you sure?" prompt and actually delete it.
Thank you.
Otherwise it'll pop up a prompt when you delete it every time.
And that just isn't fun.
Oh, yeah. Okay, we have two versions. One is called shell and one is called report.
And I'm
Shell,
using report.
okay, yeah, that leaves the command prompt window open. If you use shell, it doesn't exit without the what am I trying to say?
I know what you're saying, and
Without the
I
/b.
told you wrong. I
Okay.
told you wrong. I am using the shell one.
Okay, so it does close the command window when you're done?
It doesn't open a command window at all because I'm running it from a terminal already.
Oh,
Visual
okay.
Studio creates the command window, and so it just runs the script.
Okay, so the /b is not needed. No, it is needed to keep it alive.
Probably.
Okay.
Probably. Yeah, I didn't find anything wrong except for the error text and finding the executable. Everything else is working just fine.
Okay.
For Eric, did he disappear? He was here. Where'd he go?
Yeah, we're trying to work out his audio. He's going to go
Okay.
away and come back.
Okay, I'll wait then on that. Eric put in two options for us for putting out more than one error, and then for unifying all the path names that were presented. So they all came out looking exactly the same. They used to come out some relative and some absolute. Now they just all come out absolute. And so all of his changes are working as well.
Going backwards a bit, the goal is to enable the use of Pnut with VSC on Windows, right?
Correct.
Okay.
And it does work. I run it under VSC and I'm able to get the error reporting marked in the file exactly like it should. One of the things that we see, and thank you, Chip, is your loader using Pnut allows us to download and run from RAM and allows us to program Flash. And it looks like our load P2 command that Eric uses doesn't support programming Flash yet. At least it doesn't offer help command lines that tell me how to do it. And so what I'll do is I'll have a second download task in our tasks file. Once I get everything working, I'll put one in there that says download to Flash or download to RAM.
Using Pnut.
Correct. And the other downloader too, if we can get that to work.
Well, this will be really helpful because now we can compare compilation results
Correct.
quickly. Right now, it's kind of a hassle. When we
Correct.
publish code, we got to run all over the tools, and it just takes a lot of time to get everything up and running and all the source code in the right place. Maybe it's fast for you guys. But
That suggests that we want a Pnut unique task as well. Let the default be FlexSpin and then put Pnut suffix tasks in.
just another, maybe you can modify that JSON. Is that the thinking? So we could have another, just call a different compiler with a keystroke, different keystroke.
We'll do different assignments. One for, we'll have compile current file, compile current file, download to RAM and download to flash would be the 3 keystrokes. And we'll have it on Windows environments. We'll have a Pnut set and we'll have a other tool set. And if you're only running Pnut, you'll only have the 1 command set. But if
Very
you
nice.
also have FlexSpin installed, then you can run either of the commands.
Yep.
Eric, I wanted to let you know that since you're here now again, welcome. Thank you for the changes to your compiler. And your changes work. And everything is working fine.
Great. Is my audio working fine?
It is now.
Okay, it is this time. Okay, I had to restart Zoom.
You're recognizable. as
Okay.
you know.
Okay, great. Well, thanks, Stephen.
Sure.
I'm glad it's working.
And the documentation for the task file, I'll have an update for that for FlexSpin and for Pnut sometime later today. And so I'll post that at the site and we'll have examples for how to do that. So I think that concludes my adjustment. Oh, one more thing for the task. The download task. I found a defect in it in that if you have a window other than your top file open, when you say download, it tries to download the wrong binary. So I'm actually adjusting the text file, JSON file, to actually specify the binary just like we do for the top level file compile. So that'll all be visible. I'll put the update notes on the tasks page when you go to my GitHub site.
That's great. Let me know too. Or
I will.
maybe I'm subscribed. I should get notified. I'll update the quick bite as well.
Excellent.
So Chip's work is done there for you?
He's gonna make a modification to the bash file, I think, to remove the error text file for when it's
Okay.
not needed immediately because it'll work as it is. But he can put it out with his next release and that'll work.
Good job, Skibby.
Mm.
Yes.
Well, thanks for trying that, Stephen.
Mhm.
Well, we could move on to new topics then if we want. One item came up in discussion, wireless programming.
Oh, I haven't tried that yet. I think something was released that we can do something with command line.
Handy-Anbieter.
Hi, Peter.
Hi, no.
So wireless programming, I think that's about Prop Tool or VSC or all tools.
Wireless programming added tool.
Yeah, Brian, you were asking. Where are you, Brian Thomas? Come back.
Where'd he go?
He threw out a big question and he walked away.
Oh yeah, I was mainly concerned. I knew that would probably go to one of the others first, but I'm ultimately interested in the prop tool.
Okay.
Okay.
Yeah, and I don't know if any of us have the latest on that. It's not integrated right directly into Prop Tool. That's what you're asking about. We just have the binary drag and drop onto the WX module solution in place. Yeah. Well, you know what? I'll ask Jeff. I'll send him a message in the meantime because I think this was something common, ready to go almost, as I recall. So he's the right person to ask.
It really came in. I was looking at the activity board, and that can do it through Blocky Prop. Is that right?
Yeah.
So I was just hoping it would come to Prop Tool eventually.
Yeah, now that you've got something that moves around, you don't want to have a cable on it. I'll get an answer from our team. Well, Chip, do you want to talk about power?
Yeah, sure. Let me share my screen here.
And if you're not ready, we can wake up Lachlan because he's here.
I can do it real quick.
All right.
It doesn't take that long. Let's see, portion of screen. Okay. Let me just spit everything into this window. So we've been running some, we've had an interest in determining how to measure power, what the power consumption of the chip is. And it's kind of tricky because it's like an FPGA. I noticed when we were using FPGAs, at some point, the vendors quit publishing power consumption specs and they started giving people spreadsheets to help them estimate what the power consumption was going to be, because depending on what they're doing, it could be all over the place. It's very like application dependent. So let's see, let me bring in my little viewer here so we can see, you guys see this picture?
Mm-hmm.
Okay. So what I have here is a P2 eval board, right? And I'm bringing in 1.8 volts. I've pulled the jumper off. I'm saving it there so I don't lose it, but I'll put it over here. I'm bringing in 1.8 volts. I have a big 1000 microfarad cap here to ground, which is just kind of barely hanging in that hole there. But then over here, I'm supplying, yes, about wireless versus wires. Wires are the bane of things. Too many wires. So here's our power supply. So I have this thing outputting a little over 1.8 volts because it tends to drop, about 60 or 70 millivolts under load. So I want to get 1.8 volts to the chip. So I run it a little hot on the power supply because these things drop voltage as that current passes through. So what we have here is the chip running. If you look at this, it's 180 megahertz. Let me re-download this. We're drawing about 1.25 amps at 1.8 volts, which is super high. So we've always been kind of feeling around like, what can we do to make the chip just in the core take as much power as possible? And so we've come up with all kinds of things. What we do here, let's see, this little loop here launches all the cogs, right? And then the last one that launches is 0, which is the one it's running to launch the others with. So these 2 instructions in this 7 get all the cogs kicked off running this code down here. So the first thing to do is just do a wait just to make sure that everybody's in and we're not starting to rewrite memory before everyone's already, loaded up. Then I could have, every cog does the same thing, but it happens quick. They all fill the entire hub RAM with random data and the LUT with random data. Then we turn on the color modulator just to be obnoxious and cause more current draw. And I fill it with random values, all the coefficients. And we turn on the streamer and we're running it at, this means every single clock output on the streamer. And then we come up with some, this here puts the cog ID number up into some bits that wind up in these nibbles and these 2 configuration values. And we have 2 different things here. This one will read along every clock. Whoops. Hold on. Every clock, this one will every 4th clock, it will do a read long. So it's pulling along through the FIFO. And then over 4 clocks, it translates each byte through the LUT and then writes it to the pins in the DACs. And in this one, I just added before we got on, this takes a little more power. This is as power demanding as I could figure. So every single clock, it's exercising the FIFO. It's pulling 32 bits out of the FIFO on every single clock. And then all 8 cogs are running the same program. So this is really taking a lot of current to do. In fact, watch this. If I turn this exonet off, right? If we just don't turn the streamer on and I re-download, the power goes down 350. I mean, that's like, it's like 40% increase just to have the, but the reality is no one's ever going to run all 8 streamers at a long per clock. You can do it, and on occasion you might have a cog or a couple cogs that are doing that, but never are 8 cogs going to want to do that at all times. But by turning that on, we can go from 900 milliamps to, add another 350. So that added a lot of juice. And then down here, in fact, you know what, let me change this thing around. I'm going to make this a little more aggressive. I'm going to say, repeat 3 instructions and do it infinitely. Oh, whoops. This was DRV not, right? Okay, and then we don't have to have a loop. There. So now it's just going to repeat these 3 instructions. It's going to flip a certain pin that relates to that cog, and then it's going to stuff random values into the Cordic and do a rotate. So it's just going to keep issuing these. So the Cordic can receive an instruction every 8 clocks. So this is going to take 6 clocks here, right? It's going to take 2, 4, 2, 2, and 2, 6 clocks. So this is going to run. It's going to keep the Cordic super busy, and it's never going to take a break. So if we run this, it might be about the same. I know that's interesting. It dropped way down. Why is that? What if we don't do this and I just make 2 here? Okay, so I guess we were somehow missing the Cordic window. So it's more important to stuff data into the Cordic. So we got the power even a little bit higher doing this.
It went up to 133, didn't it, from 127?
Now, if I put this back in, oh, it did. I'm sorry, you're right. Okay, so there's a little more juice. Okay, that's good. Oh, and one thing I didn't mention is right here we turn on all of the pins into sync to ADC mode. So I chose that mode because it's doing these huge parallel accumulations, right? So lots of bits are changing on every clock. So it's toggling most of the flops. Well, probably over half of them on every single clock. So this is a way to really make the smart pins take a lot of juice. So if we turn off the thing that enables the smart pins, if I cancel that out, we can go from 1.33 to a little less. Didn't make much difference. I think what would make the difference though would be putting the pin into ADC mode. Yeah, well there's, that makes a difference. I don't know why enabling it didn't have the same effect, but anyway, we have a recipe here for maximum distress. This is like every muscle in your body doing everything it can all at the same moment, which can't really happen, but it's a way for us to, push things. So realistic power consumption at this frequency is probably a fraction of this, maybe a 1/5 or a 1/6. In fact, let's see if I can get another app here. Save this. Let's take this NTSC PAL. So here we are running at 300 megahertz. We're running 1 cog, and we're generating video. I download this. That's 0.4, which is a good amount. Anyway, I'm going to post this into the Pnut version thread if any of you guys want to play with it. But if you can drive the 1.8 volts with a power supply where you can monitor the current, you can find out what things take. And we could come up with like tables for, if you're doing this, add this for this frequency, or scale it then by this frequency. But I think in the end, applications are complex enough. You just need to take the current measurement and kind of go by that. But we'll have probably some guidelines in the data sheet for, roughly what you can expect. Because if you do turn on like all the DACs, you have a lot of 3.3 volt supply current, dumping in the pins, creating a lot of heat. So you probably wouldn't want to run every single pin in like 75 ohm DAC mode. That would take a lot of power. Any questions about this?
So Chip, what's the temperature on the chip doing?
Okay, good. Let's run this really tough one again. The chip, let it run for a sec. It's getting hotter. So it's pretty warm. It's not that, you can't easily keep your finger there. Let's give it a few more seconds. It's mainly the heat is pushed to the back of the board, which is which is what you're supposed to do with this exposed pad package, is have a via array underneath it, like a big stack of vias that go out to some large copper on the bottom of the board. So it's making the bottom of the eval board a little warm. Let's see. Right, I can feel it under here, but it's just warm. It's not, I wouldn't call it hot. I'd call it kind of warm, lukewarm to warm. The top of the chip, a little hotter, but it's not at all, not nearly unbearable. It's just, I'd say it's between warm and hot, but not really hot.
Chip, you need
So-
to get an IR temperature sensor so you can aim it at it and get real temperatures instead of it feels warm.
Well, yes, but I don't have that in front of me. Let's see, if we're taking 1.33 amps at 1.8 volts, that's 2.4 watts that's happening in the core. Okay, so that's about it. That's what I've got to show about power. Oh, I can give a little more info. So the reason what's prompting this right now is that we've never had good metric tables of our Propeller chip in like the DigiKey website, because they have all these attributes which you can list and like how many PWMs does this chip have? So for microcontrollers, they have all these criteria, and we need to fill in some of this data because we've never really had any kind of story to tell through any of that criteria reporting stuff. So we've got this spreadsheet now, which has all kinds of this stuff, and it's all tailored for different, see, I can maybe show you that. It's tailored for different vendors. Like Mauser has its own set of criteria. DigiKey has one. What's the one in Europe, Ken?
RS components.
Yeah, RS Components has
It's
another.
a master list of filters, so we can get the P2 presentation straight with all the distributors. Because some of them just, I don't know where they got it, but like 2 cogs or weird information about it that's not right at all. Probably because we put it in there ahead of time.
Yep. Let's see. Here we go. Okay, so let me pull
And
this
for the
out
data
here.
sheet too, Chip. I don't know if you mentioned that.
Yeah. Okay. Yeah. Oh, yeah. Oh, I didn't want that to happen. Let's see. Okay, so here's one for, this is DigiKey. So DigiKey has these criteria like core processor, core size, things that are kind of pedestrian. And so we have some for Mauser. Here's RS Components, and so on. Anyway, it turns out that this chip was it was anticipated during design that this chip was going to consume a lot more current than it wound up consuming. So On figured that we should make it be able to handle like a junction temperature of 150 C, which is very excessive, and we're not self-heating to that point. So what they did is they said, okay, if you want 85 degrees C ambient, let's go 50 degrees C hotter than that, and then throw in another 15 C for margin. So 85, that's 65. So the 85 plus 65 comes to 150 C, which is what everything was, all timing in the tools were closed at a junction temperature of 150 C. So Von Sarvash and I, or Michael Mulholland, we've been working through this. And what we figure we can do is, that was so conservative that rather than, we went through all these calculations last night, considering the theta JA of the package, which is like 20.2 degrees C per watt dissipated. And working all this out, instead of saying that at 180 megahertz, this chip is good for 85C, we can conservatively say it'll go to 105C, which is like kind of a stop point in temperature criterion. So 105 is, I don't know what that qualifies as. I don't know if that's industrial or what, but we're going to say it's good for 105 at 180. But we're going to, he's got an oven built up with some special articulators that can, what are they called? The things that measure temperature that are
Thermocouples?
Thermocouples, yes. And he has some like thermal goo that has really good heat conductivity. So he's going to put a dollop of that on there. So they've got this thing that they can assemble outside of their environmental chamber to push all of the thermocouples into place. And then the whole thing can be moved into the oven, and then they can crank the heat up and then do some checks. But Michael said when he was last checking this, he was able to run at 320 degrees C using our earlier test program, which is much more realistic. Let me load that up. It's called Power Check 2. This program here runs at 180, and it's gentler. It's feeding the Cordic pretty often down here. And it's running all of the pins in PWM output mode, but it's not outputting, it's not enabling the final output buffer. That's because this bit would have to be 1 to do that, but it's causing the pin though to exercise internally in the core, and it's not doing any streamer stuff. So this thing here, if we run this is only taking like, 3/4 of an amp, a little more. It's quite a bit less. So we're figuring this is probably more of a realistic metric. So going by this, we think 105C at 180 is good. But he was finding that running this test, and we don't know what kind of chips we have, right? Because the foundry can deliver you a gamut across process corners, and we're assuming we have something that's probably typical. But he's able to run this program 320 megahertz, and it didn't fail until it got to around 125 to 130 C in the oven. So that was like pretty hot. But when we get to worst case dies, which we don't know if we'll have, it'll be lower than that. So we're just going to try to remain conservative. Come on in, sweetie.
Hey, Chip.
So we're going to have eventually we'll eventually have a table. Uh-oh, interweb is unstable. Can you guys hear me okay?
Yep.
Okay. We'll eventually have a graph of, what we think is, temperature versus operating frequency, kind of a 2D curve that shows, where the safe area is. That's our goal, to come up with that.
Hey, Chip, you're running this on a Res B?
Yes.
Okay, so the current should be the same on a Res C, right?
Oh, yeah, it's the same thing.
Okay.
Yeah. Okay, so I'll stop sharing this now. Hold on, sweet. Okay, so what else can we discuss here? We've got, let's see, 26 people on board. What are you guys interested in? I see Ken's on the phone for some reason. Okay, let me share one. For those, okay, so Michael tested out our the stuff into Peanut to do the compilation from the command line. But let me see if I can pull. Let's see here. Oh, why does it want to expand? Okay, hold on. I'm going to pull this down a little bit. Hopefully I don't out-res everybody. Okay, let me go to the bottom of this. Okay, here we go. So these things over here in this column are command line possibilities for Pnut. So if you just type Pnut, whatever the current version is, it'll just start the program. If you put a file name, it'll open up and load that program. Now, it used to be that Spin2 was always insisted upon that you'd have to leave off that extension, but now if you use it or don't, or give a completely different extension, that'll all work. So you don't have to put the Spin2 extension if you've got a Spin2 file, but you can, or you can call out a file with another extension, and it'll load it up. It's same in every case of the file name use. So now if you do a -C, this has been the case, run the compiler. -R will run the compiler and run the code by downloading it. This will run, whoops, this will run and do debug. This will put it to flash, and this one will, compile, flash, and debug. And then this last one was added recently. This is a way to just have Pnut handle the debug, so that if you've programmed the chip with some debug stuff and you want to later run it, and say you're out in the field and you've got a cog that's always doing debug stuff that's not interfering with your main processes, you can just run this thing as shown here, and it will actually reset the system afterwards, and it'll do the initializations for all the windows, and it'll bring up your debug windows and keep updating them so you can watch that. So anyway, in every case, there's an error.txt file that the Pnut will write. So in benign cases where you just start the application, it just writes, okay. But now when you get into compilation, anything that runs the compiler, which is the C, R, R, D, F, and D, it potentially can output this. If you have a compile error, it will output the file name with the complete path, colon, line number, colon, the word error, and colon, and then an error message, which has spaces in it. That's why we had to get crazy with the batch file to convey that without second guessing what it meant. So that's what Stephen Rocco used to grab the error. If I go down a little further in this thing, we have some batch files here. Now this one here, let's see, I just added two. All right, let's see. Let me call this, let's see, error, I'll cap it. Okay, so what we do here is we turn console echo off, we delete the existing file, although Pnut will always rewrite it. And we just pass the first three parameters because we only have, in this case here, this is the most extreme, we have 3 parameters. So it just passes the first 3 parameters onto the actual Pnut executable. Then it immediately captures the error level in a variable called Pnut error. And now here's this crazy looking thing here is what copies the error.txt file into stdout and stderror. And Michael Mulholland, I don't know how he found this. I've never seen this tokens equal star thing before, but that's what's needed to get the spaces out without causing things to be lost. And then in the end, we exit with the Pnut error. And that takes the error level and passes it on out from Pnut. Let's see here. Let me also just do this while I'm at it.
You could probably just say deletes the prior error.txt.
Yeah, good idea. Okay.
Make it a little more clear.
Yeah, what the point is.
Mm-hmm.
Okay. Let's even just say file here just to be really what we're talking about.
Nice.
Okay. Oh, and then this one, the only difference in this second one is this. The /B says don't shut down the console window, but leave it open. That's the only difference between these two files. And I'll update these in the zip. But anyway, so that's how this error scheme worked. We couldn't have, because Pnut, hey, hold on. I can't hear. I gotta have quiet, okay. Because Pnut is a GUI, it cannot write. It's my understanding, it seems to be the consensus on the net, that you can't write to these STD error. So we have to wrap the thing in this batch file in order to capture this stuff and convey it as if this thing, so these batch files effectively turn the Pnut program into a console program, because it will block. Unlike, if you were to launch this at a command line, you get a prompt right away. But within the context of a batch file, it blocks until it comes out. And the next thing it does is this.
Now, the one thing I saw, an additional observation, Chip, in the cases where I failed to give it a file name, it just pops up a Pnut window and leaves it there, empty GUI.
Yeah.
Which is kind of interesting.
Well, because it thinks that you're not, it thinks that you're running it as the normal, application and not
right
with a command line.
So what we might do, of course, you can't predict where the file name is going to be, can you?
I don't know. See, that's why we have all these switches here. This is the only way I know you want to do some command line activity.
Yeah.
Is these things here. This is the only way I know. These dash things.
I was going to request that you put in file name test for exist, but you'd have to, there's a whole bunch of processing to figure out which argument the file name's carried in if you do that. So let's not.
Well, I just assume it's the first one, right?
You do currently, yeah. But I suspect in your app, you don't do that.
Oh, do I? Well, no, I have to. I check. I do an if file exists, and then whatever that argument was, and then if file exists, whatever the argument was, .spin2. So I check for both.
You check for both. What we could do is since you require the file name as the first parameter, you could put a test here that says if %1 exists, and then not fire Pnut if it doesn't.
Oh, okay.
Just as a thought.
And what this helps is people debugging this thing, right?
People actually getting their tasks.json file correct.
Yeah.
Yes, because when they run it with a file name not being passed correctly, all of a sudden Pnut starts up and you're sitting there wondering why it happened.
I gotcha. Okay, so if if a file name is given but it does not exist, I should write that to error.txt file.
That's probably
okay.
A right way to do it.
Okay, all right, I'll add that in. So if file exists.
Rather than just starting the app.
Yeah, then Pnut, okay. And else some kind of error.
Sure.
Yeah, otherwise we're kind of flying.
Or something, yeah.
Okay, good idea. Yeah, I'll put that in.
I'm always looking to make the exception cases a little bit more understandable.
Right. That's, yep. Well, we'll put those in there. Because I agree, it could cause someone to not understand what's happening. Give them no clue.
Mm-hmm.
Does anybody know? I mean, I could put this in the documentation right now. Does anybody know the exact command? I think it would just be like this. If.
Oh, I could look that up for you.
Okay. Well, we can do it later, but
Sure.
It'll go in there eventually. And then we need to check for the .spin2, and that requires some special syntax, to append the .spin2 to the %1.
So it's literally if exist.
Like 30 people on here I'm talking to. Okay, I'll let you see it. So if exists,
Right.
Okay.
Okay, hold on. If. What the heck?
Can get this worked out a little later because I'm sorry. We can
Yeah,
get
no
this
worries.
worked out a little later because I think when we run into the .spin2 check, we're going to have some fancy syntax issue that we're going to have to resolve through some tests.
Yep.
You know,
No, I'll be able to set up a test case for you and send it to you. I'll just do that in private message.
Okay. Okay, yeah, that'd be good. That'd be great.
In my batch file, I just do delete the file, but it could put a warning or an error in there.
Yeah, what we're trying to do is abort on the case if the source file doesn't exist, Ray.
Okay.
Not let it start Pnut. And so it's a little bit more of a test case there. I'm trying to understand the syntax. They're using
When it gets into this scripting for batch files, there's all kinds of, some of this stuff is legacy, some of it I think was introduced later, but there's all kinds of cryptic little weird tricks to make things work.
That's actually saying echo to standard out and then redirect standard out to standard error is how that reads. That echo piece.
Okay.
That's all that means. And so that's a traditional, that's very
That's
very
old,
Unix. Yeah.
but this is weird.
Yes, agreed.
Okay, well, that's something we'll get resolved in the next day or so.
Yep.
I would have a question about Pnut in general. Is there a Linux version available, or does it run under Linux in one way or the other? Can you make it work?
Well, okay, this is an ongoing theme here on this whole thing because it's actually written in 380 assembly, which is the PC architecture. So it could be run under Wine, is my understanding.
Okay.
Actually, oh, sorry.
No, go ahead, Eric.
I was just going to ask you, Chip. I can run it under Wine to compile, but I can't get it to download stuff.
Okay. Yeah, there's. I need to figure out. I have no idea why, but this is like trying to get something to run on the Mac. If you can figure out the weird way to code it, you can get it to run on everything. But there's no document on earth that can explain to you what to do.
Yeah, I've been able to run it under Crossover, which is an enhanced version of Wine.
Oh, okay.
Were you able to download with it? That's the part I'm stuck on.
No, I run a separate command line using PropLoader.
Yeah. Chip, it seems like it keeps rescanning the ports and not finding anything, even when I tell it I want to use COM2.
So, and you see the little light come on the USB, like the prop plug or whatever you've got?
I'm actually not sure. I haven't checked on that, but it never finds the prop, even though, like, if I run a command line tool, a Windows, the Windows version of load P2 and say, use COM1, it'll work.
Okay.
So something's funny about but just to let you know.
Yeah, the problem would probably divide between, am I just not calling it up right, or do you see the light flash on the prop plug indicating that it did make the USB connection to the port, but I have some kind of timing issue between my application and what's going on with the chip that USB adapter is talking to.
I can just try it here.
One solution would be that you just call the prop loader or P2 load.
Yeah.
Oh yeah, I've done that, but it means you don't get debug.
So I mean, Pnut could do that.
Let's see, compile and load RAM. Oh, huh. It does seem to hit the ports, but it says no hardware found on COM1 through COM99.
Okay, so there's some kind of timing issue. I mean, I don't know if it has to do with my generation of the reset signal. And are you using a prop plug or something else?
No, I'm using a P2 eval board. I just have it plugged in.
Oh, okay. So that'd be like a prop plug.
Let me just make it repeat and see if yeah, no, it's not actually running, but it does seem to hit the
Okay.
port.
And this is this a Linux machine?
Yeah, yeah. So I'm running it with Wine, and as I say, if I run the Windows, I can use Wine to run load P2, the Windows version of it, and that does work. So I can talk to serial ports okay with Wine, but there's something funny about the setup that Peanut and Wine aren't getting along, which is, I mean, it's understandable. But if there's just some way I could, maybe is there a way we can just force it to always use COM1 and never to scan?
Well, I guess I could add that, but if it's not finding it on the scan, it's probably not going to find it if it just looks just at that, because it does sequentially go through everything it sees as a serial port. And so it would just give everything the same treatment. It would just give one the treatment it's already giving COM1.
Maybe there's something though about the way it's scanning for the ports that Wine doesn't support, so it can't find.
Well, if you're seeing those lights flash,
but I am seeing lights flash. Yeah,
that means it is communicating with the port, but I've got some kind of timing problem, and I don't know if it's because it's been virtualized in a weird way on the Unix system, you know, through the Windows emulator. I mean, there's got to be some kind of, it's got to come down to more likely a timing than a data discrepancy.
You're probably right.
And I don't have any Linux machines, so I don't even know how to go about, you know, resolving this. But we know that load 2P works, right? And that's what FlexProp uses.
Right, and there's a
download.
That's right.
I got some files I'll share real quick. Last night from Roglo or Roger, who's working on the quad SPI RAMs, you know, for the 32 megabyte P2 Edge.
Oh yeah.
He sent me these binary files, and I'm like, oh man, I'm not really versed on the whole P2 load. What do I do with this? And I thought, wait a minute. I looked at the file and I recognized it was just a raw binary file. So I figured in Peanut, this is all I had to do to run it.
Question for Martin. I'm not sure if we further confused him with the answer, or if you followed the whole discussion.
It's a morass.
No, I think I'll poke around in the forums probably, and yeah, maybe try Wine and you know, and give that a try at some point. Then
yeah, or FlexProp is native on Linux, so you can try that too.
Yeah, Eric has written a really nice tool that actually has, I don't know, several languages, including C, that can communicate through another little app that's companion to it to download to the chip, all under like Mac, Unix, and Windows.
Oh, okay, good. That's
and
good.
Then he keeps his compiler, his spin compiler, very compatible with Peanut, which in Peanut then goes into this other thing we have called Prop Tool, which is a much prettier application, which you know, gives you file window panes and everything else you'd expect. Like,
and I'm a ping pong ball between them, trying to run code from both compilers on whatever operating system I have to see if it all works.
I've got three different, speaking of pinball, I've got 3 different machines, 3 different OSs, 3 different P2s, all set up so I can run Visual Studio on all of them and prove that it works.
Yeah,
it does.
It does. It's quite nice.
We play ping pong, so you don't have to.
Yeah.
See, this is the Propeller tool app that just runs only on, well, it's native to Windows, and it downloads and everything, and it colorizes and does stuff like this little piping from the repeat to the long to show you what's in that scope. And there's a whole file pane I closed. I don't know how to get it back. Oh, there it is. This is what I work on, this little program called Pnut, which is sort of a development test bed. And then Jeff takes that stuff and plugs the latest version into this program. And this is the Propeller tool. And then Eric's system is kind of similar to this, but runs on multiple platforms, which is a big advantage.
Yeah, it's not as pretty as that, but it.
Good, I will give that a try then. That sounds great.
Yeah, this whole compatibility thing. So we've gone, Martin, back. Well, what I want to do long term, which kind of interests me, is put it all onto the actual P2 chip, so that you don't even need any PC of any type, and that would work fantastically. The only issue is that there's, people only have so much room for monitors on their desk, and they don't want to have to like plug and unplug stuff, or usually have I would have separate monitors available for that, but it asks a lot of people to, kind of have a whole nother setup, hardware setup from their central PC, because they also want to be able to get on Windows or it's not Windows, the internet, and look around and grab files and do this stuff, which the P2 wouldn't be good at. But if we did put the tools directly on the P2, we'd have lightning fast, responsive debug. We'd have, download time would be about 0. And we could make things very real time, whereas with PCs, there's always latencies. You can maybe move data quickly, but there's always like a group latency that everything suffers, which kind of like impairs the user experience of working with it, because we're all just used to waiting. But it's nice if everything is faster than your brain, so that you never have a reason to quit thinking about anything.
Yeah, I think that second monitor problem isn't not really that a problem, because most monitors have multiple inputs where you can switch in between.
Yeah.
So I think you don't need to plug and unplug all the time. You kind of can just switch on the screen to another input. Most of my monitors do that.
That's what I do now. I do have this remote. I use these 4K TVs that are in front of me in portrait mode, and I have some prop stuff plugged into other ports, so I could just use this to switch. It works pretty well, but it's always cumbersome, and if you hit the wrong button and you don't want to accidentally turn the TV off, because then Windows goes through this huge gyration of like resetting all of the resolutions and the portrait modes, and finally getting back like 30 seconds later to where you left off.
Well, we need a web browser on the P2.
Yeah. Yeah, the trouble, I think can you imagine what it takes to implement an effective web browser these days? It's got to be just layers and layers, and what would probably into maybe 100 megabytes of junk.
Yeah, but basically the Edge with those 4 hyper-RAM, this would be a perfect development platform, I think. That doesn't take that much space. And you have with Argos video driver, basically you can drive anything. HDMI, VGA, even composite. I mean, whatever you have, you can use it.
Yeah, we can drive everything. The trouble is, when it comes to digital, we're limited to, at 60 frames per second, we're limited to 640 by 480. However, a lot of TVs and monitors will support 30 frames per second and even 24 frames per second. So if you have a monitor that's compatible with that, because we really don't need 60 frames per second for programming, 30 is quite sufficient. So if you can get by with 30 or 24 on your monitor, then you can easily get 720p timing working. And 720p is that, what's the dimension on that? It's 1280 by 720, I think, which is pretty decent. And we can also do, on analog, we can do 1080p, no problem, over just 3 pins. That's in component mode, YPRPB mode, which is disappearing from newer TVs.
Yeah, but I'm all for that you spend some time into the P2 version of this pin compiler. That honestly would be nice to have.
Yeah, it means translating everything from x86 assembler though, doesn't it?
Oh, it'd be no problem. I would just rewrite it in Spin, well, I actually started doing that. I started rewriting the compiler in Spin on the P2. And as I was doing, but I got sidetracked a while back. Now I need to get, the biggest thing on my plate now is to get the single step debugger done. But as I was working on getting the compiler running in Spin 2, or in Spin 2 on the P2, it was kind of growing Spin in little ways. I realized that we needed for Spin to support like the RF-var and RF-vars, which is a hardware level thing inside the chip for expressing constants in compact formats that are variable depending on bits in the data as you read it. And so if I did a full compiler in Spin 2, then I'm sure it would like cause the language to become a little more like bigger languages that, system level people are used to. Like we'd run into the thing where we need to make strings more comfortable. We might need to do floats. And Eric Smith's been working on floats. He's got some single and double precision libraries that are working now in his tool.
Yeah, actually they work in Pnut too. I made sure.
Oh, okay, thanks. So they're libraries that you can call.
Yeah, both compilers actually have some bugs with floating point. I think I posted yours about the negative number, and
I already forgot
both
about
a little bit inaccurate with converting some constants. So there's a
You said the DAT section winds up with errors, but the cons resolve properly.
The con was okay. The DAT came out as 0, and the pub and pry came out as the negative of the integer that represents the float.
Oops.
Yeah, I think this happened because in my resolve constant routine in the compiler, I made some accommodations for register numbers out of DAT sections. And I think I probably was insensitive to what, protecting the floats got through okay. And so they probably got clobbered. Maybe I don't know what happened. I'll look into it. I'm sure it's something simple.
It's yeah, and it's only negative floats. Like positive floats come out fine. So.
Okay. Yeah, sorry, I already forgot about that. I'm writing it down again. So see, to put floats really into the Spin language requires some like rethinking of syntax and other things. Right now, we realize these operations through, objects that contain methods. So you'd have to have something like f add, and then you put your 2 terms in there, and then it returns to you a single that you can assign to a variable. But it would be nice if directly in Spin you could just say, a plus b if they're both floats, and it understands. But then we start to get into typing, and that it opens a whole box of complexities.
It is a can of worms. Now, I've seen some languages where they actually have different operators for the floats, like they do plus dot is floating point add, and minus dot is floating point subtract.
Oh, I kind of like that.
That's might be easier to do in Spin.
Yeah, that would make it way easier. Now it'd be a pain to explain to a student why you're doing that, because the student starts out thinking in decimal, you know. But it would simplify things, and we've done that for some stuff, for some operators. Like we have signed and unsigned comparisons, you know, which we use a plus sign. I think instead of like less than, you can say plus less than. Then it will do an unsigned compare, as opposed to an implied signed compare. I'm kind of a fan of using operators to get around typing issues.
The other option might be to do what BASIC does and have some kind of suffix for the variable names if they're floats.
I see. Yeah, I see that. Yeah, that would be one way to differentiate.
My preference would be to leave in the floating point constants, continue to use the methods for now, and then you can always upgrade the compiler later, adding operators.
Yeah. Well, I think we're there right now, right? We have these libraries working thanks to Eric.
Well, I'm talking about a prop resident system.
Oh, okay. Gotcha. Yeah, I forget, you know, I know that Eric, your float routines are actually RISC-V stuff that's been kind of transcompiled, right?
No, they're prop PASM. They were used in the RISC-V code to implement the floating point operations.
Okay.
So they came originally from prop GCC on the P1.
Okay, so they're C.
They were PASM assembly written inline in C, and then I translated them to P2 and used them in the RISC-V, and now I pulled them out and made spin wrappers for them. So those ones are pretty ugly. There's actually 3 different floating point routines. There's the PASM, which are really ugly. Then there's a spin one, which is fairly clean, but it's just pure spin.
Yeah.
And there's also a decimal floating point also in pure spin that uses base 10 instead of base 2. So
right. Do you know the PASM one? Do you know about how many instructions it is? Because the basics for float operations are the conversions between floats and integers with different rounding and truncation. And then you've got add, subtract, multiply, divide, and square root. Those are like the most base functions, right?
Yeah, I don't know. As I say, the code is pretty ugly, and it's got 64-bit and 32-bit versions mixed in together. So it's bigger than you need for just 32-bit.
I wonder how many, I mean, I could eventually just put that into the interpreter, right? It's kind of assumptive that people want to use floats, but it would be there. But it might only add like half a K to the interpreter or something.
That's a good question. Yeah, it probably wouldn't be huge if it was just the basic add, subtract, multiply, divide. And you could run it from hub.
Right. Yeah, that'd be the way to do it. You know, when Eric had this idea, right? I guess he has an implementation of a way to store floats where rather than assume everything is binary, so you have a 7-bit exponent, right, in a normal float, and you buy it, so that's going to be 0 to 127. So you make 64 your like 2 to the 0 base. It's called, what do they call this? An offset or a base?
An offset, yeah.
An offset, yeah. So that way you can go, you know, down 64 and up 63. So you can have 2 to the 63 down to 2 to the minus 64.
Well, IEEE is actually an 8-bit exponent.
Oh, okay. So it'd be plus 127.
2 to the 127, yeah, plus or minus 127.
Okay, yeah.
That's for the binary.
Okay. So I forgot, because I've written things that translate from that format to decimal before, but I think I had to have like a table of every, because there's this crazy thing that you have to do, take like a floating point, kind of a virtualized binary number, and then they have some crazy offset, crazy exponential, or, you know, bit offset. It could be way left or way right of your virtual decimal point in binary. And how do you translate that into decimal? It's kind of a head scratch. And I think that I used a table to do the first part of it. And I don't know that there was a better way around that, because you have to get things in terms of tens, you know, if you're going to express things in printed numbers that we want to look at. But Eric had this idea where you take that 8-bit exponent value and you actually make it a tens exponent, so that it simplifies the heck out of your translations in and out of floating point. But it causes some lumpiness if you're looking at the like floating point. What would you call it? Like its resolution, it becomes a little nonlinear and lumpy, right? Because now you take that exponent, you have 10 to the plus 127 down to 10 to the minus 128.
Yeah, well, actually, for the decimal one, I shrunk the exponent, so that's probably why you were thinking of the.
Oh,
I had to lose a bit on the exponent in order to make room for the. Because.
Oh, did you grow the mantissa then?
I grew the mantissa because it has to be able to go up to 9, but there's no implicit 1-bit in the IEEE binary.
Right.
There's you can assume that the first bit is 1, but you can't do that with decimal because.
Yeah, that's the other part. That's the secret sauce, is that your 23, 24-bit mantissa is actually, or is it it resolves, it's like normalized to 0 to 0.999999, right? Or
1.0, it's normalized to 1.02 whatever. In the binary one, it's 1.0 up to just below 2. And in the decimal one, it's 1.0 to just below 10. 9.
Yeah.
Yeah. So the decimal version of the floating point uses a mantissa that's between 1 million and 9,999,999, which fits in 24 bits.
Right, 24 bits would give you 16 million, but you're capping it at 9.999 million.
Yeah.
Yeah. So.
Yeah, so it loses a bit of precision there. Actually, almost literally a bit.
Yeah.
But it's a lot easier to work with. And I just stole a bit out of the exponent because, you know, with the exponent being a power of 10, it goes a lot further than a power of 2 anyway.
Yes. Oh, sure does. But see, here's the thing though, when you have binary exponents, you have this like super fine granularity. You know, as you run out of mantissa on one end, you just you know, the exponent ticks up by 1. And so you have this like continuous resolution. But if we do this 10 thing, I guess we have that, well, no, suddenly we're shifting a whole digit, right? But I guess does it in the end come out to like about 1 bit is all that we lose? 1 effective bit?
I think, well, generally, yeah. I think so.
It's kind of a head scratcher, but if it's only 1 bit, that's not really a big deal. But see, my thought was that if we suddenly have to shift the exponent by 1, and that means we're now times 10, we've just rolled against 3.5 bits.
Oh, actually, yes. Actually, you do when you jump up an exponent. Yeah, it shifts. It has to divide by 10.
Yeah. So at those transitions, we lose over 3 bits of resolution, right?
Yep. About 3 bits because you round.
Yeah. But that's the cost of sanity in converting between decimal.
Yeah, it depends what you're using them for. And that's why I wrote both, and they're both there.
Yeah.
So we can pick. The
Yeah.
decimal one is so much easier to think about, you know, because it's
Yes.
it's the number.
Well, not only that, it's only easier for the programmer to think about that has to deal with it at the bottom level, but it actually, the numerical anomalies that occur make more sense to the person using it, right?
Yeah.
That's the real sales point, is that you're not going to wind up with these strange, like, why did my number do this when I divided it? It'll do more sensible looking things to the person thinking in decimal.
Yeah, that is the advantage.
Can you get more significant digits and less exponents in there to make a more usable number?
Unfortunately, no, because it's to get another decimal digit, you need 3 more bits, which would take your exponent down to 4 bits, which doesn't give you very much range at all. At that point, you pretty much might as well just use a fixed point.
Damn.
Yeah, that's the hard part of decimal. It's greedy on digits. Now the IEEE guys actually have an official decimal format, and it's really fancy. They do this weird bit packing to recover that lost bit of, and they let the exponent go up to 96, and they pack the leading digit gets packed in, so it can go from 1 to 9, which is just over 3 bits, like, and then they pack some extra range into by encoding it, but it's more trouble than it's worth, in my opinion. In software, it's a real pain to decode that.
Yeah, this thing has been squeezed from different ends for decades, I think. This goes back to the 60s of how to encode decimal numbers in binary. And there was something called, was it POSIX or no, POSITS? Someone else had a thing where, you know, there's a problem, like say you take 1/3, right? Well, you're always going to get some horrendous fraction that can become non-repeating at some point because it's not really 1/3. And so there's some number storage formats where they actually preserve like reciprocal, like they'll put a flag in to say reciprocal, you know, so that you don't suffer these kinds of things. And then have not just exponents, but some attribute that indicates how many of these digits are really significant, or how many bits of the mantissa are really significant given our work underway. And so it kind of like, you know, flexes through all these computations and tracks all these things, and in the end can give like more sensible looking results that have to do more with the real input numbers that went into the equation.
Yeah, I haven't looked at that yet.
A few years ago, there was all this talk about it. It was like going to be the new thing, you know, to replace floating point. But I think where they just keep doing more bits to floats and just keep powering past things that way, and then relying on rounding and whatnot. Anyway, there's only so many combinations you have with so many bits. I remember once when I was 15, I was thinking about data compression, but I didn't know what to think about. And I actually went to bed one night convinced that I had found a way to compress, like, I don't know, it was something like I could take 24 bits and always pack it into 20 bits, because I had these like 2-dimensional puzzles that would solve. I didn't realize that there were like probably 16 you know, solutions to every one of these potentials. But I was thinking this is going to be great, because I'd made this thing called IcePick that would capture games and then compress them. And now I was going to be able to have like a 3-block file that would have every, but it was just fantasy. I didn't know, you know. Other people were telling me it wouldn't work, but I was convinced that it was going to work. But now I just realized in recent years, well, not super recent years, but why stuff like that doesn't work.
So you mentioned they keep adding more bits, but I'm not aware of any new floating point formats that go beyond the 80 bits that we had on 8087s in the 70s.
128 bits is pretty popular now.
Okay, well, maybe not.
Well, you're talking like AVX 512 and the other high-end add-ons. Do they actually do 128-bit FP math internally? Because I didn't think they did. Those are just like combined registers that let you stack multiple 64s and multiple 32s.
I'm not sure which hardware, which chips have hardware support for it, but it's certainly fairly widespread in software implementations anyway for 128-bit floats.
Okay. Yeah, we had
That's
80
probably got like
ancients ago.
Yeah, it's funny in this space of like what can happen with bits. I think it's been banged around into every extreme possibility, and what exists now is about what can be done. Although there is that one quote by that guy named Julius Fontinius in Rome 10 AD where he said, I think we've posted it here before, that said something like human, or what did he say? Design has long since reached its potential, and I see no hope for further improvement. I think with finite numbers of bits, I think it's kind of been pushed out to everywhere it could go at this point. But there might be some undiscovered thing.
Might be some interesting venues in the quantum computing areas.
Yeah, I was listening to some guy talk about this quantum computing stuff, and my understanding was he said that when you add quantum bits, you're actually like not linearly increasing your states. For every bit you add, you're like exponentially increasing your state space, which is so hard to think about.
Eric, your object you're writing, have you decided to go with the decimal point, or are you trying to go IEEE?
I've written 3 floating point objects and posted them on the forums. So one uses decimal, one uses binary, and the other one is the assembler that does both 32 and 64-bit binary.
Is floating point, of those that are on video, raise your hand if you'd like floating point at all in some form. Okay, maybe 3 out of, let's see, I see there are 6 of you. Oh, there's Mike Green, he wants it. And then how many would like to see it native to the language so that you don't have to use a library?
Yeah, I'm raising my hand virtually.
I'm raising about 15 hands.
I'm raising my hand too on that one.
I like that idea with those operators like plus dot, minus dot. You know, that part would be nicer than method call.
Yeah, because that magically gets us around the typing confusion.
Right.
Yeah, so everything can just remain longs. Brian, are you talking?
Yeah, just be aware that you're going to have casting issues and type issues when you're multiplying floats by non-floats and so on. You're going to have to figure out rules for upcasting and downcasting.
Well, it's going to be the programmer's responsibility, which means there'll be all kinds of weird bugs.
Well, I'm saying
if why there's no need for special operators. Let the programmer deal with it.
I'm just saying if Chip implements it in the language and you do X plus Y and they're different types, it's either an error or you have to cast.
Oh, I see. You're saying
and so you have to implied cast or you have to explicit cast. So either the language does an implied cast and there's no error, or it's required and there is an error unless they put the cast on.
Yeah, so detect what you can in the compiler and warn them.
Or just have a set of rules and do it the same way and let them read the docs, which is how every other language does it.
Well, I think the proposal was that the operator would say, you know, this is a floating point add, and there wouldn't be any types associated with the variables. You'd say x plus dot y, whatever bits are in x and y.
Oh, so you're talking about changing the operators too. So that's not the same as what everyone was suggesting earlier. Like they want to be able to just do x plus y and have it work for floats, not x plus dot y, which is a different operator.
Yeah, well, adding types to spin would be a whole other.
That's what I'm saying. Like that, if you add it to the language, it brings along a whole pile of baggage with it that you have to consider.
Well, you mean I think adding types is 10 times as complex as adding operators that are for floats, right?
I'm just saying like you can't just say I'm adding it to the language without caveats, because it won't be added to the language in the way most people would expect if it's different operators for floats versus non-floats.
Yeah, no,
it's really not that different from calling methods if you have to use different operators for floats. So you might as well just leave it be calling methods in an object.
Yeah.
And not calling methods as opposed, you know, you can work with brackets and have more of it in one line and not float add a, b, float divide a, you know, I think an operator would be nicer as a method call. And I think also that would be probably quite easy to implement. And Spin already has lots of weird operators combined, or letters for an operator, so it wouldn't really disturb much.
Yeah, so at one extreme, you'd have like things like float add, parenthesis, a comma b. At another level, you would have a plus dot b. And then at the deepest level of implementation, you'd have a plus b with an awareness of what a and b are, right? I kind of like the middle one best because it's the simplest. It doesn't get us into typing. And it gets us out of the morass, well, out of the overabundance of text to just add two floats together.
Yes, and on the other hand, if you can say a plus dot b is a float operation, and if you say a plus b, then it will get casted to integer.
Well, there won't be any casting. It'll just treat it as an integer.
Right.
Mm-hmm.
Yeah, so the
programmer, which is very different than casting.
Mm-hmm. Yes.
Yeah, the programmer would have total control over what operations are happening on those variables then, which I kind of like because I'll tell you, the worst, the most pernicious, difficult to nail down problems I've had of late were in the debug stuff where I have all those graphics and I do a lot of like, because there's a lot of scaling involved, I use some floating point for some of those displays. And those bugs are the worst to track down, you know, because you get these crazy things that would never happen if you're just dealing with integers, you know, in doing like conversions from float to integer. I had some real pain in the rear issues. And it was so tricky to track all that stuff down and figure out where it was coming from. It went on and on for like three bug chasing iterations. I thought I had it nailed every time, and more headache kept percolating up. And it was the float stuff. It's good in some ways, but it brings about so many deep, subtle problems that can like present over time that you just don't know about at the outset. And you have to be really aware of what you're doing to avoid that stuff in the beginning. Yeah, Ray?
That was what I was raising my hand for a minute ago.
Oh,
I was just
yeah, you were muted.
Yeah, I was just wondering how many of those people, me included, would lower our hands if that was going to delay your single step debugger.
Oh, yeah. You'd rather have the single step debugger?
I was
Yeah.
just curious how many hands would have went down and how fast they would have dropped.
Okay. So yeah, single step debugger, it's like right on the cusp. I've got the disassembler written for it, which was the big thing. And I just need to get on it. I mean, I'm kind of at this point free to do that. Although I got to figure out what's up with the floats in the DAT section. But I work, having finished this command line stuff, I think for now, that was the last big thing before I could get back to the debugger.
And Chip, are you done with the visual debug tools so that if Roy successfully ports that, we can ask Eric somehow to look at it too?
Mm-hmm. Yeah. Yeah, I've given them, I gave Roy the code and a few others.
Anyone out there with that code have any success in porting it?
Has there been any changes to it, Chip, since
No.
a few weeks ago when you gave it to me? Okay.
No.
We're terminating further changes on Chip for visual debug.
As if you can stop him.
I know.
As if you, yeah.
So it sounds like he's done enough, Roy, that maybe you can get some cross compilation success going. Who else has it? I think Ray has it too. Or do we have connected efforts in this way?
All I've done so far is just use some tool I found that converts Delphi to C, but it has a maximum number of lines unless you spend several $1,000s on the tool. So I ran it a few lines at, 100 lines at a time through, and I'm trying to then make it work after that. And because it's not the whole program, it does weird stuff in the conversion.
Yeah, it doesn't know context.
Loses context, yeah.
Bummer on that. So it's really a few $1,000s for said tool, huh?
It's very expensive. It's, but it's not really necessary to pay for it. I think I got enough out of it that I can then, I just have to spend the time to go through it little by little and convert it.
So do you anticipate success with that effort looking forward? You do?
Yeah, I think it'll work.
So if that's
the main thing is coming up with cross-platform rendering, because it's all Windows stuff right now, and I'm gonna have to use some library like SDL or BGX or something.
So you know what? Everything that gets drawn is through those anti-alias routines I wrote. So they're just dealing with RGB bitmaps.
Yeah, no, I know, but I still want to do that in a cross-platform way, and there are libraries that will let me do that, so I'll just do that.
Mm-hmm.
So providing you succeed, then Eric might be able to take a look at it.
Yeah, I'm not sure how we would.
So my thinking, Eric, was that it would be something that we potentially integrate into Load P2 or Propeller, or whichever one, and it would enable when you told it to, and when the program started feeding back the debug serial stream, it would just intercept it and start drawing stuff. It's like Pnut does.
Yeah, that makes the most sense. I agree.
And it's a relatively tiny ad that way too.
Yeah, we'd have like an option to load P2.
Currently, it's a debug option on Pnut, so a similar option would make sense here, maybe.
Yeah, basically, the main issue is that you would lose you're not going to have a terminal a normal terminal interaction because it's all the debug stuff coming out of that port instead.
Yeah.
And then for some of your extensions to it, like the PC hosting and whatnot, I'm not sure how that will work.
I wonder if there's a way we could, for the PC file system, the way that works is it sends a special character, like an escape sequence kind of thing, that load P2 interprets. I wonder if we could do something like that for debug, where like all the debug commands are prefixed with some sequence that isn't a legal Unicode character.
Yeah, you'd have to make the debug runtime code that gets downloaded into the P2 do that, because that's where it comes from, right? It's
yeah, well,
whatever chip compiles in with Pnut into the binary that gets downloaded in the P2, it has the extra debug stuff in it that outputs that stuff.
Yeah, that's FlexSpin works quite differently from Pnut in that regard.
There's also the fact that the debug port can be separated from the standard serial port.
Well, it'd certainly be nice to be able to separate it. But
yeah, I'm saying it's a directive in the source code right now where the debug is routed to.
Which pins do you mean? Or?
Yes, correct.
Oh, okay, that's a different matter, yeah.
Yep. And so what that means is that your directive to download would have to identify then
which serial
port to be receiving, correct, a different
yeah.
port.
It'd be nice if we could multiplex everything.
Yeah, it reduces the bandwidth on the serial port, but yes. Because it's an interesting volume of data for most of the uses. Most of the
I mean, the terminal is
something real quick.
Yeah, the terminal is kind of unusable if debug is enabled because it's spewing text constantly. And to be clear, what I'm porting is just the stuff that runs on the PC side and interprets the strings in the serial into rendering, opening windows and rendering, not the stuff that gets downloaded into the P2 at all.
Yeah, that's a whole different can of worms. But that'd be really nice to have, though, having the PC stuff portable.
Yeah, here's a chip showing the Pnut running as an intercept tool, right?
Right,
to do the debug output.
Yeah, so I can see this command line. So Pnut v35L, that's the latest version, -debug, and then port 6. So I'm going to run that, and then it opens up the debug window at the top of the screen, but I'll drag it down so you can see it into here. Now when I turn on my board, now note there's nothing compiling, right? There's already an image in the flash. When I turn on, let me go like this, and we can't see the edge of that. Well, there's nothing there anyway, but now watch when I flip on the power. Come on. Okay, here we go. Flip the power on, boom, and then you can't see it, but I'll drag it down. It's running this thing, which is showing the these push buttons.
Yeah, that's another possible interim step, Eric, is to just run this as an option from FlexProp. If they run a program that has debug, they could optionally run Pnut with a command line like that.
Well, if Pnut worked on Linux.
Right.
Or it doesn't work on Linux, but at least on Windows,
yeah,
it could be an option.
No, that's true.
But
until I get
also,
the stuff ported.
Roy, that also suggests that yours as a standalone executable could have the same options and then be platform independent.
Yeah, possibly.
I think the integration into P2 load and the P2 terminal could basically be another debug screen, sort of. So basically, like Eric is now filtering the P9, the Plan 9 things out with an escape sequence. He could filter out debug with an escape sequence, and the rest runs into the normal terminal window. Should be possible.
Complicated.
Yeah, if the code that was put inside the P2 that was sending the debug stuff prefixed everything with a escape sequence, it would be pretty trivial to, you know, filter those out of the terminal output and send them just to the debug stream.
Yeah.
Seems like the way to go, at least for right now. When debug has two-way communication, that's when things get more complicated, and that's coming up with the single stepping.
Yeah, I got a question in that regard. Chip, every version of Peanut that you put out, you include the P2, it's underscore spin2 underscore debugger. Is that the code, the debug code in its entirety that's included when you debug? Is that the, you know, the code that resides on the chip?
Yep. Yeah, that's it.
Okay.
Yeah.
And that gets loaded up into that upper 16K, right?
Right.
Reserved.
Yeah, also the flash loader is what gets loaded, well, just appended to your, prepended to your app so that it can be programmed into the flash. That's another file like that.
Okay.
When we're ready, we have MicroPython question. Are we done with the tool, that end of the tools for now? Kevin, Stephen, Roy, Eric, Chip.
My keyboard malfunctioned. I was trying to type a question there. Did I hear you wrong? Did you say that we had multiple ports? One for debug and one for regular UART?
You can configure it so that the debug will come out on different pins. And if you hook up a different USB to serial to those pins, then yeah, you would have debug coming on a different port.
That's the output from Chip's debug statements.
And since now you even can set the baud rate different.
Oh yeah, if you set the baud rate to something other than what it downloaded at, you might need to put in a debug delay, which you know gives a time for pause before it starts outputting debug messages. Because what happens on the PC side when we download the application, which is immediately followed by the debug stream without a delay, if there's no delay, what happens is when I would go to change the baud rate, there's still data that's queued up that's going out to the P2, part of the application. So I do on the PC side always before getting, if there is a difference in baud rate, I always do 100 millisecond delay to allow the rest of that data to stream out before I change baud rates, anticipating debug data. But sometimes there's needed on the debug side a delay on that end too, to so that it doesn't start sending out debug data at a different baud rate than what I'm holding the baud rate for, so that the rest of the data can stream from the PC. And it's really, I don't think there's any way on the PC to know where you're at. You know, it's too high level. It's like you load up buffers, they start sending out, and there's no way to know if you're done or not. There must be though, right? There's got to be something at some level that would tell you that. I haven't found it. And it might become driver specific, you know, like you might have to know if you're using FTDI chips for USB to serial, you might have to interface to their app. But that gets to be too specific. But there's no, I don't think there's a general way to know if your buffer is flushed or not.
That delay is required whether you're changing the board or not. So if you download it at 921.600, and then you said debug 921.600, you still need that delay. So you must be still sending that command out.
Yeah, in my experience, there's no reason to see, as long as you don't reconfigure the UART, the virtual UART, it's gonna keep sending and receiving data at the baud rate. So it doesn't know if that's the end of the application being downloaded or the beginning of the debug data coming back. In my experience, it doesn't matter, but when you change baud rates, you suddenly have to have time awareness.
What I'm telling you is that delay is required even if you don't change the rate, if the rate's different to 2 megabaud. So in other words, if you download it at 921K and then you debug at 921K, if you've got both those commands in, you need that delay as well. And your version K or L fixed that. That delay, that extra delay command is required. Otherwise, the very first time you do it, and it's only the very first time, you don't get a display in the debug window.
I wonder, is it because we missed messages? Because see, never before, when we were running everything at 2 megabaud all the time, never was there any need to do any kind of delay on the PC side. Only when I shift gears. And here I can, let's try this here. On here I have this 5 buttons on 1 pin program, right? So if we go download baud, what is that number? It's 9 what?
921.600.
Okay, so now it's gonna, the debug baud is going to inherit that same value unless I override it, right?
Yeah, override it, Chip.
Okay, well,
Put the next one.
Let me close what else is going down. Now let's just run it like this. Okay, this is working, right? See this, it's doing everything at that baud rate.
Yep, but
Without
Chip, Chip, you haven't reset your board and you haven't restarted Pnut.
Wait, reset the baud and restart it.
Reset your PCB.
Okay.
So unplug it out of the USB port and plug it back in.
I just hold the reset button down?
No. Got to make sure, because I don't know. I don't have a reset button.
Okay, so you know the prop plug, you want to plug the USB from the prop plug, right?
Yeah.
Okay. Done. All right.
And close Pnut and reopen it.
Close and okay, hold on. All right, well, let me just launch a new Pnut. There's none running right now. I'll just say. Okay, so here we have one. Hold on. All right. So now what?
Now load your little simple demo.
Here it is. Now I haven't changed the baud rate in this one. Let me see. Let me save it.
Grab your real simple demo, because then you've got none of this other stuff in the road. Your debug demo.
Well, this
and then if you change it, you haven't got anything worry. It's easy to go back and fix.
It's okay. I've got this one here because I know this one's going to do what we want. So see, I've got the download baud right here, right?
Okay. Yep. And then change debug board to the same value.
Okay.
Yep. And now run that.
All right. Now I'm going to run this with debug, right?
Yep.
Oh, wait, what does it think is open? So, oh, well, I got to plug the prop plug in, right? I got to plug the
Yeah,
USB
yep.
into the prop plug. Okay, here we go. Do this. All right, now I'm going to run this with debug, Control F10, right?
Yep.
Why is it like, I've never seen it do this. It's like locked up.
Yeah, I wonder if your other peanut stolen the port still.
Okay, let me unplug the prop plug. There we go. Now I'm going to plug. Okay, I've got that back, and let me replug this again. Now if I do Control F10, let's see. Well, now it's not even, oh, you know, I think sometimes Zoom has weird effects on things. My whole application, I can't even touch. Let me stop sharing for a sec here. Yeah, Zoom was inhibiting it from going. Okay, now I'm going to do the Control F10, and it's running. Let me share again. And I can bring this down. So this thing's working.
Okay, well, with your simple demo and the P2 eval board, so that's taken all my stuff out of the road, I can absolutely tell you the very first time you do it, if you don't have a delay between the download board and the debug board and you use that speed, the very first time you do it, you get a blank screen in the debug window. The second time you hit Control F10, it's fine. So it's the very first time that something is not being initialized within the time or something's happening, but it fixes it with the delay.
So with the delay, it works the first time.
Yeah. And that's what I put on the internet. I thought on the forum, I thought I was quite specific in exactly what the circumstance was. But yeah, the very first time, and totally repeatable. Unplug, relaunch Peanut and repower the P2 eval, which I'm getting the power from USB port. And it'll fail hard on every time.
Okay.
And 100, yeah, it's fine.
Yeah,
Clock frequency doesn't matter.
Now it's working again.
Yeah.
Okay, so because see, in my experience, if I have the debug baud different from download baud, I need to put a delay in here. But you know what? I actually have the compiler just kind of do that. I think I could have it automatically add some time delay. Maybe even make it 200 so that it certainly there's a nice overlap, you know? Okay, well, I'll try to recreate what you're seeing because I haven't seen that. I did see my program lock up, but I think it had to do with Zoom. Let me stop sharing again. You know, I'm gonna run your test again. I'm gonna set the debug baud and the download baud to the same thing. I'm gonna unplug the prop plug, right?
Yep.
You gotta close and reopen Peanut.
Oh, we have to do that too?
Yes. Yeah. Yeah. It's,
all right.
I think it's tied up with something in Peanut the very first time. But, you know, as I said, the delay fixes it. So.
Yeah. Okay. So now I'm going to run Peanut again. Okay. I've got my thing. Add this and okay, here we go. Now I'm going to try to run it. It works okay. You know, it might be something about it, something on your PC, something about how your system's handling serial ports. It's a little bit different than mine. Because I just started everything from scratch and it ran the first time without a delay. See, this is the thing, if we ever put the tools on the chip, we completely get rid of all these kinds of problems. They all go away because there's no more unknowns and things that are completely out of our control that we're never going to know because there's not enough time to investigate all these things.
Yeah.
Yeah, so Ray, that seems, it doesn't do it on my computer, but it does it on yours. So it's got to be something about the way your drivers are relating.
Main problem with putting it all on the chip is that I can't run my 3 4K monitors from a P2.
Well, and then
You
we
have
have
to
to
go
make
to
sure
HD mode.
we have to make sure nothing happens to chip.
You could run your 2K monitors full blast. You could run your 4K in HD in regular 1080p mode, but yeah, you couldn't. You know what? We have the ability to analog signal super. We could do what's between 2K and 4K is like 2560 by 1440. We could actually signal that in analog, but no monitor will take that signal. It's kind of frustrating. We could generate that analog signal, but no monitor will take it. They demand it in digital beyond 1080p.
Yeah.
Now, okay, Ken mentioned that somebody had a question which was about MicroPython. And let's see, where is Lockness here? He could probably answer it.
Okay.
Hi, Chip. Yeah, Carol.
Hey, hi there. And hey, Carol, we haven't seen you for a while, Carol. We were wondering where you went.
I'm building some robots.
That's good.
Like, I'm hoping my printer, which is close to this computer, isn't causing any noise. It's 8 hours into a 117-hour print.
Oh my goodness.
A giant robot. Anyway, my question is, I'm working on a cyberbot and I need it to move more naturally than it does. So I was wondering, is there any way to address the cogs in the propeller that's hooked up to the MicroBit?
Well, the MicroBit, this is more Ken's domain really, but I believe with the MicroBit, the propeller, you're talking about the cyberbot, and propeller does control the motors, doesn't it? So I would think that there should be a way of getting one of the propeller cogs, P1 cogs, to handle the servo.
Yep. But what is that way?
Oh, I have a example I can share with you right now. There's a undocumented command called accelerate.
Okay.
And just to be clear, you're using the MicroBit, right? Not the P2 MicroPython interpreter.
No, this is on the cyberbot.
Okay. All righty. Gotcha. Let me share a screen and then I'll email you over some code.
Okay, is that on the web or anywhere?
Yeah, I'll share this out with you.
Okay.
Here you go. This is what you want. Oh my gosh, this slideshow's gotten so big it hardly loads. So you can put this accelerate command in your program once and then it will stick throughout.
Okay, how does that put code in a cog?
Well, you're using the MicroBit, right?
Yeah.
So this actually talks to the propeller 1 through the Cyberbot code module.
Okay,
and the propeller manages it in a cog. So you don't have cog cog level control in your MicroBit program.
Okay. So can I put several things into cogs with this?
Well, you're using cogs without directly controlling them from your Python program.
Okay, so 10, 18, and 19.
Yeah, I'll just send this right over to you. I'll just paste it into the chat for you.
Okay, because I want to put, I was going to leave the motors in the MicroBit and then put the flashing eyes and stridulation from the mic.
So you want to control the motors from the MicroBits library, not from Cyberbot module. Is what you're thinking of doing?
No, it runs the motors fine because I've got the walking crawl kit on the bot. But I want, as it's walking, for the feelers to flash and the stridulation from the mic to be going at the same time as it's walking.
Oh, I gotcha. Okay, let's jump into a breakout room. I think I can make a room and I can meet you over there right now. So I'm going to move you out of here, and then we'll chat about this.
Okay.
So, Chip, I'm going to make you host just in case something gets lost on the way. Okay, Carol and I will go and resolve this, and we'll be back.
All righty. There's been, I was just looking at the forum, there's some interest in initialized Vars. Have you guys been reading this?
Yeah.
Oh, Chip, you got to name me host again. Sorry.
Okay, how do I do that?
Just right click on my name under the participants list and then say make host. Once I give away the control.
All right.
Yeah.
There we go.
Okay. I think everything will work out. We'll be back in a bit here.
All right. So is there any interest in initialized Vars?
Going down this path, Chip, you're going to quickly turn spin into C.
Oh, I know. I don't want to do it.
There's no reason to do it since a DAT section will do exactly the same thing and give you the ability to access named entities like they were variables.
Right. No, I agree. I think that what Rayman was thinking was it's nice.
It didn't look enough like C for him. That's what he was saying.
No, I know, but I think it has to do with positional issues. Like most people, most of the time, the DAT section is this big thing at the bottom of the file, which has all the crazy stuff in it. Well, you can make
not in my code.
Well, yeah, you can make as many DAT sections as you want. If you want to,
I do, yeah.
Okay, so if you want to have some DAT stuff that's just related to one method, you just put a little DAT line and then whatever you want to declare in there, and there you have a table, which I like that way because what I hate about modern stuff is that everything gets hidden from you. You never know where anything actually, it's like there's a conspiracy to keep you in the dark about what's really going on and where everything actually is. So I kind of like to let computers be computers and have like data in memory that you can access, you can index, you can modify, you can do all this stuff in. That's, to me, like what's going to happen at the bottom level anyway.
Well, like I do small DAT sections and even small con sections that are associated with specific methods just to make everything nice and neat and tidy. And like you point out, to make it very visible so that nobody is running around guessing, trying to find something. Now, I certainly have programs that have big sections of, you know, of constants, but I try to minimize that, because to your point, programs should be easy to read.
Yeah.
We often forget that that the text that we're writing is for humans. A compiler will deal with whatever we give it, as long as it's syntactically correct.
Yeah,
Yeah, the main caveat between DAT and var is that the DAT there's only one of, and var there's one for each instance of the object. And so you have to, if you want to keep a separate copy for each object instance, you have to copy from a DAT to a var and use the vars.
Right,
But you couldn't.
Yeah.
But if you were, so I want to make sure I understand what you're saying, because I saw that and I was shaking my head thinking that if you have a defined object, the initialization code is already in that object. So if you instantiate another copy of the object, you're going to get the same variable initialization, are you not?
No, I'm saying, what I'm saying though is that if you want your variables to be independent for each object instance, but also be initialized, then you have to copy from the DAT to vars.
Yeah. Okay. I understand that.
Or runtime explicit initialize. Yeah.
Hey, thanks for coming, Martin. I see that you're going to go to bed. You probably guessed Michael Summer over here is also from Germany. But he lives near us.
And he has a lot less hair now.
Okay, so I didn't mean to interrupt you guys. I just saw Martin saying goodbye.
Sure. John, I think your organization of your code also lends itself nicely to when we're building code from your examples, we can cut and paste only the related sections. And we don't have to figure out from a very large DAT section which DAT pieces are related to the part they're copying. So that works very well, your structure.
If we would use names which have more than 2 letters.
He does mostly. He's in good shape.
I do.